So now you got yourself exposed to the idea of finding the inverse of a function in a restricted domain. So let's now do a couple more examples to get yourself really comfortable with the idea now. So once again, I have a function. Here, example number 8, just like the same idea. We want to find the inverse. The function that I'm looking at here, in this case, is x minus 2 all square. But then, like I said, the type of problem, now we're trying to find the inverse of this function, but in a restricted domain. So now I'm looking at x less than or equals to 2. Okay, so now that's how so here remember, this little condition here is a restriction to our domain here. We have a restricted domain. So besides that, the rest is carried out just the same as we've done with those proper steps for finding the inverse. So first, I'm going to need to replace the f of x symbol on the left hand side here by a y variable. So here my equation become y equals x minus 2 in quantity square. And once again, keep in mind the conditions, the restriction of the domain keep coming along. You need to keep writing that condition along. And now step number 2 is to interchange the role of the x and y, to interchange x and y, the two variables. So here in my equation, y becomes x and x becomes y. And so as you verbalize it, x becomes y, that means in the conditions it changes the variable too. So my x in the condition becomes y, but here we have y less than or equals to 2. Okay, so once again, keep in mind right at that step where you're interchanging the variable, make sure every x is switched over to a y and every y is switched over to an x. So now proceeding on, now to solve for, we need to solve for y. So I am going to take square root of both sides to solve for y. I need to take square root both sides using the square root property. So now I'm going to encounter x, square root of x, but then with a plus and minus square root of x, because square root always come with two separate ones. And now on the right hand side, y minus 2. And now finally, to solve for y, I just simply need to add 2 to both sides of the equation. That gives me y equals 2 plus and minus square root of x. And keep in mind, all this here solving for y is my step number 3, and the condition keep coming along. Y is less than or equals to 2. Okay, so now this equation here can be rearranged as y, one variable y, but equals to 2 plus or minus square root of x. So this final equation that I am circling right now, it means two things. And by the way, here's the conditions. It means two things. This equation in the circle means two things. It means on one hand, I have my y variable equals to 2 plus the square root of x. And on the other hand, y would be equals to 2 minus the square root of x. So keep in mind, one y variable equals to two different things. So now, what helps us decide which of these expressions here, you see where my fingers are pointing at? I have two expressions, both equals to y. So now, which one of these is going to win the battle to become the inverse functions? The answer is in this condition right here. We're going to choose whichever one here between the two expressions here. Which one is going to give me a y value less than or equals to 2? That is the one that's going to be my inverse function. So now here we're going to have to do a little test. Once again, choose a value of x. And as I'm choosing a value for x, you can have your own choice for x. But make sure you compute properly. So here I can choose, now notice x here is underneath the square root, so I cannot choose a negative number. I must choose a value like say 0 or above. So let's say I'm going to choose x equals 1. Okay, so choosing x equals 1, that's going to give me on the, if you're looking at the left expression right here, choosing x equals 1, your y value is going to be 2 plus square root of 1, because I'm now just simply substituting x equals 1 into my left hand side expressions, and that is going to produce for me 2 plus 1, and that equals 3. So if y equals to this expression 2 plus square root of x, then when x equals to 1, y value would be equal to 3. But this is already violating the condition, because we want y less than or equal to 2. So here we cannot choose this one to be my inverse. So now, but let's check with the other one. Once again, choosing x to be 1. If y equals to the other expressions, then what's going to happen when x equals 1 is we have 2 minus square root of 1, and that gives me y equals to 2 minus 1, and that equals to y equals to 1. And now y equals 1 makes it consistent with the condition that says the requirement here is y is less than or equals to 2. So now it seems like, so as the way how it tests, the result turns out that the right hand side expression here is the one that passed with the conditions, that's consistent with the conditions. So now, as my final answer, the inverse functions is chosen to be 2 minus square root of x. So once again, this example here is also still similar to example number 4 that we had, but unlike example number 4 where we stop with a no inverse answer, here we can find an inverse based on the restriction, based on the requirements here. So let's try one more before we move away from this topic. Example number 9, and we want to find the inverse. Okay, and my function once again, so how about we have x squared minus 4, and here we're looking at x less than or equals to 0. Okay, so I want to find the inverse for this function in the condition, in my restricted domain, in a restricted domain, x less than or equal to 0. So step number 1, once again, I need to replace my f of x symbol with a y variable. So here I have y, my equation becomes y equals x squared minus 4, and keep in mind the condition keeps coming along at every single step that you're moving. And now the next step would be interchanging the x and y. So, and keep in mind once again, when you're interchanging x and y, make sure every x, including the x appears in the conditions, also need to be switched over to a y. So my equations together with the condition would become something like this. X equals y squared minus 4, comma, and then the condition here is going to become y less than or equals 0. Alright, so now at this point, once again, the next step is to solve for y. I'm going to need to add 4 from both sides, and that gives me x plus 4 equals y squared. Okay, and then keep in mind the condition is coming along in every single step, but now the conditions is switched over to a y less than or equal to 0. And now solving for y, I just simply use the square root, apply the square root property on both sides. And so on the right hand side I have just simply y equals to the x plus 4 quantity underneath the square root with a plus and minus in front. So I have y equals plus and minus square root of x plus 4. Or you can switch around the equation and look at that as, you can turn around this equation and look at that as y equals to plus and minus square root of x plus 4 all together. And once again, one more time I'm trying to explain this to you all. This equation, this final equation that I'm circling, that I'm putting in a circle, it means two things. It means on one hand, the variable y equals to the positive x plus square root of 4. I mean the positive square root of x plus 4. On the other hand, it also means y equals to negative square root of x plus 4. And now the condition is indicating that y is less than or equal to 0. Okay, so the point here is that one same variable equals to two different expressions. So which one of these expressions will be the winner? To become the inverse functions. And the answer relies on that. The answer relies on that condition right here. Whichever expression here gives me a y value less than or equal to 0, that expression wins the battle to become the inverse functions. And that is the basic logic right here. So now, to find out which expression here gives me a y value less than or equal to 0, I need to choose an x value. So once again, you can choose an x, a value x on your own, but here I choose x to be 0 once again. And now I'm going to have to do a little test. Now, with the left-hand side expression right here is positive square root of x plus 4, my y value is going to be 0 plus 4 underneath the square root. And so y equals to square root of 4, and that gives me y equals to 2. Okay. On the other hand side, when x equals 0, y equals to minus square root of 0 plus 4, and that gives me equals, and so y equals to minus square root of 4. That means y equals minus 2, because square root of 4 itself is 2, and with a minus it's minus 2. And so between these two answers, clearly the y value on the right column right here is the one that makes it consistent with the conditions, because no matter what x value that you choose, we want to end up with a negative. We want the expressions that give a y value less than or equal to 0. That's why my final answer, the inverse function in this case, this expression here is going to be the winner. So the inverse functions, f of x inverse equals to minus square root of x plus 4. And here I'm putting all my answer here in a box. And that is how you can find, once again, that is how you can find the inverse of a function in a restricted domain.